Hello, how are you doing? Today we'll be talking about multiplication of matrices. Actually, this is going to be the second time I'll be uploading a video on multiplication of matrices simply because there was a mistake in the first video and we had to put it there. So if you saw that first video and you probably used what we did there to solve an assignment, an exercise, or to attempt an examination, I'm sorry to say that there was an error there, so you might have written something wrong. Anyway, my name is Oluwale Godwin, if you're just joining us on Economics. So, getting to the business of the day, multiplying two matrices requires that the number of rows in a matrix is equal to the number of columns in another matrix. Actually, this is actually under a kind of multiplication of matrices, and we are going to get to that soon. But it is important to note that for you to do a kind of multiplication of matrices, you must ensure that the first matrix has the same number of rows as the columns in the second matrix, and or vice versa. Now, types of matrix multiplications. Number one, we have a scalar multiplication. So this is simply the multiplication of a matrix by a single number known as a scalar. So by the time we have, let's say, so there's an example here. So we have given matrix A to be, this is a square matrix. So it has it has two rows, 1, 2, and that's 2 columns. So given this matrix, so what is going to be Ka? K is the scalar now. So Ka is going to be, you just have to multiply every element of matrix A by K. So we have 6 multiplied by K is 6K, 9 multiplied by K is 9K, so you have 2K and 7K, and that's all. That's all about scalar multiplication of matrices. Now we assume that K is 8, assume K is equal to 8. So Ka will then be 6 multiplied by 8, 9 multiplied by 8, 2 multiplied by 8, and 7 multiplied by 8. So we have 48, 72, 16, and 56 respectively, and that is that about that. So you can say that scalar multiplication is not a big deal at all. Now scalars could be something like half. So half is a scalar, it could be -2, 0.5, etc. Now let's come to where the work actually is, which is talking about vector multiplication. Now a matrix with a single row is called a row vector. Alright, and a matrix with a single column is called a column vector. Now, multiplying a row vector by a column vector and vice versa requires that the number of rows in a row vector equals the number of columns in the column vector. So, which was what I was trying to explain in this place. So, this is actually important and useful when we start talking about vector multiplication of matrices. Now, this type of multiplication, vector multiplication now, is called a row column vector multiplication. So by the time we start showing examples of how we multiply, so we're multiplying rows by columns. However, I already stated that the number of rows in the first matrix must be equal to the number of columns in the other matrix. Right, so that would ensure that our multiplication is kind of possible. So row column multiplication is the basis for every kind of vector multiplication that you have in matrices. Okay, so by the time we start talking about maybe 2 by 2, 2 by 2 multiplied by 2 by 2, 2 by 3 multiplied by 3 by 2 matrix, and all of that. So what we are going to learn from this particular video is what we shall be applying in multiplication of such exercises. Now we have this given matrix A. So this has 2 rows, 1 row 2, and this has a single column. So this is a column vector. And then we have matrix B, which has a single row, and this is column 1, this is column 2, so a single row and 2 columns. So, and that makes this a row vector simply because it has a single row. This is a column vector because it has a single column. Now, what is the dimension? Now, the dimension of this is a 2 by 1 matrix simply because recall from our previous classes that when you're writing the dimensions, the first number represents the number of rows. So this is rows and this is columns. So we have 2 rows, 1, 2. Alright, and then we have a column, so 2 by 1 matrix. This is a 1 by 1 matrix stating that we have 1 row, that is B11, B12 is on a single row, and then we have 2, which means 2 columns, this and this. Now, if you don't really understand rows and columns very well, I would advise or recommend that you see the first video. Alright, so that's not a big deal at all. Just scroll down to the end of this particular video, then you are going to find a playlist of matrices. So you click on the playlist and that takes you to every video that we have on matrices. Alright, so now I want to do 2 kinds of multiplication. I want to multiply A by B, I want to multiply B by A. So we are doing that for 2 reasons. First is Now we want to know how to do the multiplication basically, and the second is that we want to know if AB is equal to BA. Alright, now AB is, how do we do that? Because we're multiplying A by B, the dimension of A is 2 by 1, right? And the dimension of B is 1 by 2. So first, before we attempt multiplying, we must ensure that the number of rows and columns are equal. Now this represents row, column, right? Row, column. Now you can see that the column here is equal to the number of rows here, that is 1, 1. So there is a single column in the first matrix and there is a single column in the second matrix. So that means we can multiply them. Now the remaining numbers is going to tell us the dimension of our final answer. So we have 2 here, right? And we have 2 here. This is telling us that matrix AB at the end of the day is going to be a 2 by 2 matrix. Okay, this is going to be the dimension. Okay, now so how do we do that? I said row times column, right? So this is a row, right? So this row multiplied by this column, and then this row multiplied by this column. Again, this row, this is a row, A11 is on a row multiplied by this column, and A21 multiplied by what? This column. So this is what we have. Then we are done with this, right? So we then move to B12. So we have A11 multiplied by B12, which is this, and then we have H1 multiplied by B12, which is this. Now, what you should observe here is that, or maybe when I get to the second one, okay, I'm going to explain what I wanted to say initially. So this is going to be our answer. So AB is going to be A11, B1, A11, B12, and all of that. Now, we want to do matrix, we want to do BA. So we want to get BA. Now, the thing is that B is a 1 by 2 matrix, right? So 1 by 2, we want to multiply it by a 2 by 1 matrix A, which is 2 by 1. So first we check, we have this is row, column, row, column. So we have 2 here, we have 2 here, so which is saying that the number of columns is equal to the number of rows, so we can multiply this. Oh, okay. Then we then have the remaining numbers telling us the dimension of the answer, of our answer at the end of it. So this is this. So BA is telling us that matrix BA is going to be a 1 by 1 matrix that we call a scalar matrix. Okay, a 1 by 1 matrix. Now, how do we do that? So we have this row and this column. So this is going to be B11, A11. All right. This is this row times this column. That's what I want to do. So B11, A11. But we still have a row, right? We still have something on this row. We are not done with our row column multiplication. So B11, A11 plus B12, A21. Again, B11, A11 plus the other thing on the row, which is B12, A21. So that's how to do it. Now, by the time this looks like 2 digits, right? Well, it's not really 2 digits because it's more or less something like 5 plus 3. A 5 plus 3 will give you a single number, right? So BA is equal to B11, A1 plus this, and we expect this to be a single number, and that is going to be a 1 by 1 matrix at the end of the day. If this were 3, or this were 13, and this were, let's say, 10, so 13 plus 10 will be 23, and 23 will be what? A kind of matrix. It's going to be a matrix that has a single row and a single column. So now we are going to move into solving more exercises on vector, using the vector multiplication. So this is kind of the most fundamental thing to learn. So we are going to apply the knowledge of what we've learned here in attempting 1 or 2 questions. Recall that I was trying to say that I wanted to tell us something here. Okay, so now the thing is that whatever is the first matrix that we are multiplying by another, the final result is going to have the kind of order that the first matrix had. Now, what I mean is, this is A11, A21, right? So by the time we finish the multiplication, consider that A11, A21 still maintains its position like the way it is ordered in A, and we still have A11, A21 here. So that could be a quick check for you to see what you are doing. Now, when we're doing for BA, and look at what our final answer is. So you have B11, B12, right, on the same row, and our final answer is still maintaining that order in the sense that we have B11 here and then we have B12 here. Alright, I hope you understand what I mean. So AB is going to maintain the order of the very first matrix, which is A11, A21, A11, A21. That arrangement is maintained, and A11, A21, that arrangement is maintained. And for B, you have B11, B12 on the same row, so BA will be B11, B12, and that is still going to be maintained that way. So that's what I want you people to see from there. You can easily use that to check if your answers would be right or not. Now we have three matrices here. Alright, so A, B, and C. And the question states that we should find A, B, and we should find B, C. So how are we going to do that? So we have A, since A is this and B is this. So this is, what's the dimension of this? How many rows do we have? 1, 2. And this is a 2 by 3 matrix. 1, 2 rows, 1, 2, 3. Then how about this? So we have 1, 2 as well. So this is a 2 by 3 matrix, but there are 3 columns. And then what about this? We have 1, 2, 3. We have 3 rows, right? And then we have 1, 2. We have 2 columns. So this is a, so for trying to find AB. So AB, what we start with is we have 2 times 3, right? 2 times 3, and what is B? B is 3 times 2. So this is row, column, row, column. So here 3 by 3. That this is number of columns is equal to number of rows. So that means we can multiply the 2, and then we have this. So AB is expected to give us a 2 to be in a dimension that is a 2 by 2 dimension. Alright, so let's see if that's what we are going to get. So let's just so AB will then be left to write this 3, 6, 7, 12, 9, 11. Okay, then what is B? B is 6, 12, 5, 10, 13, 2. Okay, so let's start solving. Let's start multiplying. So we're having 3 multiplied by 6. So AB is going to be what? 3 multiplied by 6, 3 multiplied by 6, plus 6 multiplied by 5, 6 multiplied by 5, plus 7 multiplied by 13, 7 multiplied by 13. As you can see, 3, 6, 7 still maintains that order, 3, 6, 7. Okay, so that's for this. Then we are not done with this column, right? So we have to multiply this by this column as well. So we have 12 multiplied by 6, plus 9 multiplied by 5, plus 11 multiplied by 13. Alright, so this multiplied by, so we are now done row, column. We are done with row, column. So we move to the next column. So here we have 3 multiplied by 12, plus 6 multiplied by 10, 6 multiplied by 10, okay, plus 7 multiplied by 2, 7 multiplied by 2, okay, so there's the matrix like that. Then we are not done with this column, we have this 12 multiplied by 12, so we have a 12 multiplied by 12, right, plus 9 multiplied by 10, okay, 9 multiplied by 10, then plus 11 multiplied by 2, 11 multiplied by 2. Alright, so what's our final answer going to be? So 3 times 6 is 18. So 18 plus 30 plus 7 times 3 is 21. Alright, this is 91. Alright, 3 times 12 is 36 plus 60 plus 14. And then 12 times 6 is 72 plus 45 plus wow, 11 times 10 is 110. Okay, then 11 times 3 is 33, so this should be 143. 143, then we have 144 plus 90, then we have plus 22. Plus 22, I think I did that already. 18, 30, 91. So all of this now, so AB is going to give us 139. So this is going to be 139. That's not wrong. 36, 60, 14. We have a 110 here. And then, let me check my notes again. 72, 45, 143. We have a 260 here. 260 here. And then 144, 90, and 22. We have a 256 here. So what's the dimension of our final answer? So we have 2 rows, right? 2 rows, and we have 2 columns. So which means what we did is right. Now let's find BC. Let's find BC. Now for us to do BC, we have to check the dimensions as well. So what's the dimension of B? Dimension of B is 3 by 2, right? And dimension of C is 2 by 3. It's 2 by 3. So we have row, column, row, column. So the same number of rows and same number of columns. Then our final answer is going to be a 3 by 3 matrix. So we expect BC to be a 3 by 3 matrix. Now, by the time we start multiplying, so BC is going to be, what is B? B is 6, 12, 6, 12, 5, 10, 13, 2, right? Then C is 17178 and 243. 178 and 243. Okay, so let's expand this. So expanding that is going to give us, so we have row, right, and columns. Row multiplied by columns. So okay, BC will then be, so we have 6 multiplied by 1 plus 12 multiplied by 2. So it will be having 6 multiplied by 1 plus 12 multiplied by 2. Okay, then we are not done with this column, so we have 5, 5, 10, and this column. So we have 5 multiplied by 1 as well, plus 10 multiplied by 2. Okay, then we have 13 multiplied by 1 plus 2 multiplied by 2. So we have 13 multiplied by 1 plus 2 multiplied by 2. So you can see that 6, 12, 5, 10, 13, 2, 6, 12, 5, 10, 13, 2, they still maintain that same order. Now we are done with this first column, so we'll move to this second column. That is going to give us 6 multiplied, we return to the first row here, 6 multiplied by 7 plus 12 multiplied by 4. 6 multiplied by 7 plus 12 multiplied by 4. Okay, then we have 5 multiplied by 7 plus 10 multiplied by 4. 5 multiplied by 7 plus 10 multiplied by what? 4. Okay, then we have 13 rather, 13 multiplied by 7 plus 2 multiplied by 4. 13 multiplied by 7 plus 2 multiplied by 4. So we are done with this column as well. So we move to the third column, multiply through again. So this row and this column, we start from the beginning again. 6 multiplied by 8. So we have 6 multiplied by 8 plus 12 multiplied by 3. So I think this is 3, right? Okay. Write it properly. 6 multiplied by 8 plus 12 multiplied by 3. Okay. Then we have 5 multiplied by 8 plus 10 multiplied by 3. Okay. Then you have 13 multiplied by 8. 13 multiplied by 8. Alright. Plus 2 multiplied by 3. So we closed the whole thing. Now BC is going to give us, BC equals, now 6 times 1 is 6. So 12 times 2 is 24. 24 plus 6 is 30. 5 times 1 is 5. 10 times 2 is 20. 20 plus 5 is 25. 13 times 1 is 13. 2 times 2 is 4. 13 plus 4 is 17. Alright, so we have 6 times 7 is 42. Then 12 times 4 is 48. So 42 plus 48 is 90. 5 times 7 is 35. 10 times 4 is 40. So 40 times 35 is what? 75. Now 13 times 7, 13 times 7 is 91. This is 7. 13 times 7 is 91. 2 times 4 is 8. 91 plus 8 is 99. Now 6 times 8 is 48. 12 times 3 is 36. So 36 plus 48 is 84. 84. Now 5 times 8 is 40. 10 times 3 is 30. 40 plus 30 is 70. 13 times 8 is 8 times 3 is 24. 4 to 8 times 1, 104. Then 2 times 3 is 6. 104 plus that is 110. 110. Okay, so let me verify. Plan BC here. So I have 30, 25, 17, 90, 75, 99, and 84, 70, and 110. Okay, so now how many rows do we have? This is the first row, second row, third row. We have 3 rows. And how many columns? 1, 2, 3. We have 3 columns. Just as we've predicted, where is it? Just as we predicted it, so we have this. Now, you can see that multiplication of matrices is not that much of a big deal anyway. Okay, or after all. So now what I'm going to do is to, as is my norm these days, so I'm going to give you exercises to do on your own. Okay, and the ones that you can leave their answers in the comment section, please do so. I would appreciate if you leave all your answers in the comment section. I would really appreciate it. So your first assignment is going to be if k equals 0.7, k equals 0.7, and b equals, and let me use this. If k equals 1/12, k equals 1/12, and then a equals A equals minus 618, then 1 over 12, right? Then 6 over 12, 6 over 12, 6 over 12, 5 over 10, 5 over 10 and 3 over 5. Okay, so find KA. So that's the first exercise. Then the second exercise is okay, that's number 1. So number 2, multiplication of matrices. So given A as 7 5, so you have 7 5 1 3 1 3 8 6, right? 1 3 8 6, and B to be 4 9 10 4 9 10 4 9 10 2 6 5 4 9 10 2 6 5. Okay, so and C equals 2 6 7. Okay, so you find AB, then you find BA, and then you find A into brackets BC, into bracket BC. Alright, so we didn't do something like this, but from what you've learned, so I think you already know what to do here. So first you deal with what is in the bracket, so you find matrix BC, then you multiply whatever answer you have by matrix A. So it's not a big deal after all. So if you have any questions, please leave them in the comment section of this particular video. Let me check something. Let me check them. Okay, I multiply them. Alright. Please, you have to state that their dimensions. Of course, you know what to do. So if you have any questions, please leave them in the comment section. I'm going to appreciate them. And if you want to comment us for what we are doing, please, you can also do that in the comment section. Refer this channel with your friends, share them everywhere. Make sure you like this video. Basically, you enjoyed it, right? Please click on that like button. Subscribe to this channel. Once you click the subscribe button, you're going to see a notification bell. So you click on the bell just tells you when new classes have been made available. In our next class, we'll be talking about minus and cofactors. I would love to see you there. Bye.